In this video, we'll talk about actually identifying turning points in relative extrema, and then I'm going to go ahead and include the next objective in this video as well, which is on graphing polynomial functions. And so recall that a turning point of a function is a point where a graph changes from increasing to decreasing, or vice versa. These points are relative extrema as they are the highest or lowest points of the points around them. The graph of a polynomial function of degree n has at most n minus 1 turning points. Think about this. If a linear function has a degree n equal 1, and if you think about the graph of a line, it has no turning points. So 1 minus 1, which is 0, so it has 0 turning points. When the degree is 2, we get the graph of a parabola, but notice a parabola has 1 turning point. That is 2 minus 1, which is 1 turning point. Now, it may not have all of the turning points, but it can have at most that. So if the degree is 10, there would be at most 10 minus 1, or 9 turning points. If the degree is 50, it would be 50 minus 1, or 49 turning points. So I have the graph of p of x equals x to the 5 minus 5x cubed plus 4x on the screen. The degree of the polynomial is 5, but there are 4 turning points. 2 of them are relative max, since they are peaks of the graph, and 2 are relative minima, since they are the valleys of the graph. So the graph starts from the third quadrant, goes up to this point, negative 1.64, 3.63. Then it goes down through negative 1 on the x-axis and goes down to the point negative 0.54, negative 0.142. Then it goes up through the origin to the point 0.54, 1.42. Then it turns down and goes through 1, 0, and through the point 1.64, negative 3.63. Then it turns up to go through the point 20 and continues up. So a lot of the things that we've talked about we can see coming into play here. The degree is 5. The leading coefficient is 1. So it's going to end up to the right, go down to the left, which we see that here. And it has at most 4 turning points, right? So 1, 2, 3, 4 turning points. If we set this function equal to 0 and solved, we would find that the zeros are negative 2, negative 1, 0, 1, and 2, each with multiplicity that is 1, because the graph crosses at each one of those zeros. So the relative maxima, remember those are the y values at those points. So the y values of the peaks are 3.63 and 1.42. The relative minima are the y values of those valley points, which would be at negative 1.42 and negative 3.63. This graph also is an odd function because f of negative x is negative f of x. Notice that if the point xy is on the graph, negative x and negative y is on the graph, so just bringing up things that we've talked about before. So to find turning points, you will need to use a graphing calculator, and you're going to enter the function in the equation editor, which is by pressing the y equals key, and then you will access the maximum or minimum command, which is obtained by pressing second and trace, and then you will get to the calculate menu in that keystrokes, and then you're going to choose either 3 or 4 depending on which one you want to calculate first. So 3 is the minimum, 4 is the maximum. And then you're going to enter a left bound by moving to a point left of the maximum or minimum point and press enter. This is a polynomial function x to the 7 minus 6x to the 5 plus 9x cubed minus 4x. And so this graph starts down in the third quadrant. It goes up to a peak, comes back down to negative 2, 0, goes up through the origin, down, and up to the point 2, 0, down to some point in the fourth quadrant, and then goes back up. And so if I wanted to find this leftmost peak point, I would have to go to the left. So I think about drawing a vertical line through those peaks and valleys. If it asks for left bound, you've got to be somewhere to the left side of that point, so move the cursor left or right as needed. And then you press enter, and then it will ask you for a right bound, so you want to move the cursor somewhere to the right of that peak point and press enter. And then it will ask you for a guess, so you're going to move your cursor back to that peak point, and it has to be between the 2 points the calculator just made on the screen, and then press enter, and then you will see the maximum point displayed at the bottom, and you'll round as needed for your homework. And so I'm not going to do a particular one of those here. I actually have a video on that in iCollege. So here we want to just graph a polynomial function, and we're going to put all of those things that we've talked about together. We know first that the graph is smooth, continuous, no holes or gaps. The degree and leading coefficient tell us the end behavior. Does it open up, to the right, down to the right, or up to the left, down to the left, those types of things. Find the zeros of a polynomial function by factoring. And then we know that there will be at most n zeros, where n is the degree. And we're going to use the multiplicity of the zeros to determine if the graph will cross the x-axis or bounce off the x-axis of that intercept. And we know that the graph of a polynomial function has at most n minus 1 turning points. So we want to use information from this section to sketch the graph of each polynomial function, identifies the zero, the y-intercept, the end behavior, and the domain. We have the function p of x equals 3x squared minus x cubed. So some things that I would first remind myself of is this. It is in expanded form, but not in the correct order. In standard form, it would be negative x cubed plus 3x squared. So we know that this polynomial has a degree of 3, which is odd, has a leading coefficient of negative 1, which is negative. So right there we know that it's going to go down to the right, and because it's odd, it will go up to the left. To find the zeros, we set the function 3x squared minus x cubed equal to 0. We can solve this equation by factoring out the common factor of x squared, which leaves 3 minus x equals 0. So we can set it squared equals 0 or 3 minus x equal to 0 to get x is equal to 0 or 3 is equal to x. So we have a 0 of 0 with a multiplicity of 2 because of that factor on x squared. And then we know that an even multiplicity means the graph is going to bounce off the x-axis at the point 0, 0. And then 3 has a multiplicity of 1 because its factor is 3 minus x to the 1. So an odd multiplicity says it will cross the x-axis at that point 3, 0. We want to find the y-intercept, that is finding p of 0, which is 3 times 0 squared minus 0 cubed, which is just 0. So 0, 0 is the y-intercept. So let's put these things together. We know the y-intercept and actually the x-intercept is 0, 0. And we know the graph also has a 0 or x-intercept at 3, 0. Okay. Well, we know that it opens up to the left and down to the right. We also know that it has to bounce off at 0, 0 and cross at 3, 0. So if I was just doing this as a rough sketch, I know that the end behavior, the graph will go up to the left, so that means it's going to be up to the left of 0, 0. And then I'm told that it's going to bounce off at 0, 0. So that means it's got to touch the 0, 0 and come back up. It's going to go up to some point, and then it, at some point, has to come back down because it's got to cross the x-axis at 3, 0. And then it's going to continue down because of the end behavior, which is down to the right. Now I have the graph drawn on the screen. I just did it on my calculator, and I actually found the maximum point, which I don't have to scale here, but it should be at 2, 4 is the maximum point. So if I wanted to be a little bit more precise, let me draw that better. So the graph is going to go up to this point of 2, 4, and then it's going to come back down. My domain is all real numbers because there's no restrictions on a polynomial function. The range in this case is actually all real numbers because it is an odd function. Then let's look at p of x equals negative x squared times x plus 2 times x minus 2. To find the zeros, we will set this function equal to 0, so negative x squared times x plus 2 times x minus 2 is equal to 0. Setting those to 0, negative x squared equals 0, or x plus 2 is equal to 0, or x minus 2 is equal to 0. So we get just x squared equals 0 when we divide by negative 1. Applying the square root property, we get x is equal to plus or minus 0, which is just 0. Then x plus 2 equals 0 gives us x equals negative 2, and x minus 2 equals 0 gives us x equals 2. The multiplicities of those zeros, because x squared was a factor, the 0 of 0 has a multiplicity of 2. Because x plus 2 to the 1 and x minus 2 is raised to the 1, both negative 2 and 2 have a multiplicity of 1. And so we know that the graph will cross at negative 2, 0, and it will cross at 2, 0, but it will bounce off at 0, 0. And then to find the y-intercept, we find p of 0, which will be negative 0 squared times 0 plus 2 times 0 minus 2, which is just going to be 0. And as far as the end behavior, this is in factored form, but if we multiply, there's no exponents to apply to these, x plus 2 and x minus 2. So we can multiply negative x squared times x to get a negative x to the 4. So the degree is 4, which is even. And the leading coefficient is negative 1, which is negative. So being negative means it's going to end going down to the right, but because it's even, it's going to do the same thing to the left, which means it will go down to the left. And so we can kind of get an idea of what's going to happen. We'll plot 0, 0, negative 2, 0, and 2, 0. We know that the graph is going to cross through negative 2, 0 and 2, 0, but it's going to bounce off at 0, 0. We know that it starts down to the left, so to the left of negative 2, 0, the graph is going down. To the right of 2, 0, the graph is going down. So that means it's going to go up to some point, and then it's going to come back down, and then it has to bounce off the x-axis at 0, 0, so it's going to go back up, but then it's going to come back down so it can cross through 2, 0. I put the graph of these on my calculator and found what the actual maximum and minimum point would be. And again, I'm not drawing these to scale in my rough sketch, but the maximum point would be a negative 1.414, and the other relative maximum point would be at 1.414. So my domain is all real numbers. In my range, if we actually use the calculator's graph, that 4 is the maximum y value, and so my range would be negative infinity to 4 with a bracket. And remember, we can do all these things about where is this increasing or decreasing, and all of those things that we talked about before, but I won't get into that now. But this is how you put all those things with polynomial functions together to be able to sketch the graph.